Okay, so day 3, we're going to be looking at trig limits. So it says evaluate each limit. The limit as x approaches 0 of tan x. So remember, the first thing of limits is always to plug it in. So this is tan 0. Tan of 0 is 0. If you think of where your tan graph starts right there at 0, 0. Right, and then you have your asymptotes and so on, but at 0, it is 0. Remember, you do not need the word limit once, if you're plugging in. So like if I'm plugging in here, pi, cos pi, I don't need to write the word limit. Pi, cos of pi is -1, so this would be a negative pi. Plugging in here, this is sine squared of 0. What sine squared of 0 means, remember, is sine of 0 and then squared. Sine of 0 is 0. 0 squared is 0. Again, think of where your sine graph starts, right? Oops. At 0, and it goes into the negatives. Okay, some kind of special trig formulas that we talked about last year, like kind of just memorizing them. The limit as x approaches 0 of sine x over x is 1. Same thing happens for tan. Tan x over x is 1. And that's because it really follows this a times b over c format. Same thing, so you would just do the a times the b over the c. If it's the limit as x approaches 0 of sine or tan, and the next two are just showing, these two right here are just showing that the reciprocals work. So if it's a limit as x approaches 0 of cx over a sine bx, c over ab, same thing for tan. Does not work for cos. Okay, and we'll see why in a minute. This is a special one. Limit as x approaches 0 of 1 minus cos x over x is 0. That's just kind of one to know. Okay, so here, this is just know that it equals 1. And last year we did talk about why that is. Right now we could think about it graphically. So if you think of your tan graph, and if you think of your y equals x graph, right here at 0, if you zoom in on 0, you can barely tell the difference between the two graphs. So that's why if you have, y equals x, which in this fraction is our denominator, and you have a, y equals tan x, which in the fraction is our numerator, if they're the same here at 0, anything divided by itself is 1. For b, we're going to just use that AB over C. So it's going to be equivalent to basically 1 times 4 over 1, which is 4. This is 1 over 1 times a half. 1 over a half is 2. Reciprocal. Now, we said it doesn't work for the limit as x approaches 0 of cos. It doesn't work for cos x over x. So, and here's why. If we think of our basic thing that we do for a limit is plug in. Cos of 0 is 1, not 0. So that's why we do not get 0 over 0 in determinable form. We get 1 over 0, which means does not exist. Maybe I should have kind of said that back over here. It doesn't work for limit as x approaches 0 of cos x over x. The reason we have to use that rule for sine or tan is because if you think about it, like if you do the limit as x approaches 0 of sine x over x, if you were to plug in, you'd get sine of 0 over 0. Sine of 0 is 0 over 0. That's the indeterminable form. That means you have to scrap it and do something else. Same thing happens with tan. So that's why for sine and tan, we need the rule. For cos, we do not. It works out to be it does not exist. Again, first thing for limits to try is a plug it in. So we're going to try plugging in. 1 plus sine of 0 is 0. Cos of 0 is 1. 1 over 1 is 1. So that one ended up being fine. The next one, if I were to plug in, I'm going to get 0 over 0 indeterminable form, right? Because sine of 0 is 0, and 0 squared is 0. So I'm going to get the indeterminable form, which means I need to do something else. So I'm going to need to separate these into two fractions. So if I think about it, this is sine h times sine h. That's what sine squared h means. And this is h times h to give me h squared. So you got to think of multiplying this through. Does this go back to that? Now, once you think about that, you're doing the limit is h approaches 0 of sine h over h, which is 1. Limit is h approaches 0 of sine h over h is 1. 1 times 1 is 1. So that's that rule, right? A, B over C. This one, if I plug in, I'm going to get 0 over 0 indeterminable form. So I have to say limit as x approaches 0. Separate this. Sine x to get sine squared x. I can make this 3x and this x to get 3x squared. So if I do limit as x approaches 0 of the first thing, I get a third, right? That AB over C. And here I get 1. A third times 1 is a third. If I plug into the next one, I get 0 over 0, indeterminable form. So I just want to know that rule, 1 times 2 over 3, so it'd just be 2 over 3. Next one, plugging in, I get 0 plus 0 over 0, so yeah, I get 0 over 0, indeterminable form. So I'm going to say limit as k approaches 0 of, now remember adding fractions, like if I want to separate this fraction now, I would have to have a common denominator. So k over 2k plus sine k over 2k. So think about it. If you added those fractions, you would get k plus sine k all over 2k because you have a common denominator. So, this would have to be these have to be equivalent. So now the limit as k approaches 0 of k over 2k. So it's a 1k over a 2k. So it's a 1/2. This is also a half. So that's 1 whole. Next one is just the rule here. So that would be 3. This is going to just be a plug it in. So 3 sine 0 minus 4 cos 0. So it's always kind of a giveaway. Like if you've got a cos 0, keep in mind cos 0 is 1. It's not 0. Sine 0 is 0. Tan of 0 is 0. But cos of 0 is not. So that's why we're going to be okay here. Because this will be 3 times 0 minus 4 times 1. 5 times 0 plus 1. So see, we're not going to get 0 over 0. We're going to get negative 4 over 1, which is a negative 4. It's only when you get 0 over 0 indeterminable form that you have to do something else. Okay, so that's it for our trig limits.